Okay, good morning, students. So, with respect to the lab sessions, I think our theory and the lab both are hand in hand. So, almost our all the lab programs, they contain about ER modeling, and it is ER models, schema diagram, how to draw schema diagram, and how to draw ER diagram, how to map it to the schema diagram, and SQL queries about creating the tables, insert statements, update statements, and finally the queries. So almost all the experiments are same. So in the first experiment, so we are doing ER diagram and we are identifying the different ER modeling tools. We are identifying different ER modeling tools. Probably you might have, this could be a generally drawn also, but there are some tools available like which we have explored, so which is like a dia tool. Similarly, there are many software tools which are available, or it can be drawn by simple by hand also. Okay, so already we are seeing in first 1 and 2 experiments a simple concept with respect to National Hockey League, NHL. There is Hockey League, so which contains many teams with some attributes that each team has a city, coach, captain, set of players, and each player belong, this is a condition, or what you may call it as a requirement or a constraint. So each player belongs to one team. Each player has a name, position, skill, set of injury, and a team captain is also there. Then the game, so which is played between two teams, and it has a date and a score. So this is a basic NHL team, simple database we need to design for the hockey league. So already we have explored this experiment, and we have also designed the ER model with respect to the above constraints. And after doing this, what we have done, we have created the database tables, and we have populated these tables with some valid data, and we have executed simple queries on these tables. Open-ended queries were there. So these queries are given to you, and accordingly I think you have exercised these queries with respect to the first experiment. Coming to second experiment, this is also the same concept, but here it is with respect to an educational institute. So where there are, we need to store attendance, IA performance, and then there are many documents required. Then you have to inform it to the parents. So you need to store the excuse me, you need to store the parent details. Then you need to store the department, faculty, head of the department, and each student, whatever he has studied subjects, and score, and whether the subject is a core or elective. So for this also you need to design a ER diagram. This also I think in the lab already we have explored, similar to our first experiment. Here also we will be understanding the constraints, and we are trying to draw the ER modeling here. So already we have done this one also, ER model, and then the schema diagram, right? So here there are almost more tables come into picture. So like tables, there are almost 9 tables. Almost 9 tables are there, so which is pretty big in this with respect to our experiments. So 9 tables are there. So one table is faculty, so where all the faculty details are stored. Then department, where all the details with respect to the department are stored. Then student, where the details about the students are stored. then subject. So which all are the subjects with the subject code, subject name and a type also, for example whether it is a core or a elective are stored here. Then the score, then score or marks, whichever is fine. Score is another table, so which contains score of the student in particular subjects. Then there is test, so test number, test date, so in which the date and the test number is being stored. Then there is attendance, that is attendance of the student is being stored with respect to the subject, date and time is being stored. And then parent details are being stored here. So these are some of the tables that are required for our second experiment, and probably using these tables I think you have done the ER diagram and also the schema diagram. And here also there are open-ended statements are there, like you need to create all these tables with proper if you see the schema diagram of this, already you have drawn this. So in the schema diagram it will be clear, that is which are the primary keys and which are the foreign keys, how these foreign keys are being linked to other tables. So all these tables probably will be, when you draw the schema diagram you will come to know that which table is, that is the data of which table is there, how the tables are being related with respect to foreign key constraint. So based on that we will be creating all these 9 tables. So once all the 9 tables are created, first thing is what? Creation of the tables, already we have done it. Next is what? We need to populate the proper data into it, and then there will be some queries will be asked to you, and already I think you have done this also, some queries, and based on the queries what you have done, we need to extract or we need to search for the data, and accordingly the queries will be giving you the results. So as we move ahead, so these are the 2 basic experiments, so which will cover ER diagram, schema diagram, and creation of the tables with constraints and foreign keys. So here whatever the problem definitions are given, so the problem definitions are like you need to explore with respect to the problem definitions. So problem definitions are given in explanation. So in this explanation you need to find out, so which are the entities and what are the attributes with respect to those entities, and you need to find out, that is how these entities are related with respect to that mini world. For example, this first experiment was dealing with the NHL, that is hockey league. So that hockey league is a small mini world where teams are there, players are there. So based on the problem definition you need to find out which are the entities and which are the attributes, what are the relation between these different entities, so which we are showing it in a ER diagram, and based on the ER diagram you will be mapping it to the schema diagram, right? So this is what the process is. So we have understood this technique with respect to our 2 experiments. So first one is National Hockey League team, and second one is a university model, that is a college model. So in this college model what we have done, it is a brief explanation about the problem is given. So college is there, staff is there, students are there. Out of this you need to find out which are the entities and which are the attributes with respect to these entities, and then you have identified it. So with respect to the problems that are given, so whatever the big problem definitions are there, that one you are making a diagram out of it, so which we call it as an ER diagram, that is entity relationship diagram. Proceeding further, hope you have already, I think this also we have explored a few examples in the theory class also, right? So already we have seen the basic things about the database management. So the basic things about database management is you need to understand the constraints from the problem. That is, we have mini world here. Mini world contains what all things? It contains entities, and in term it is attributes, and then there are constraints. Constraints in the sense the environment in which they operate, constraints. So this everything together will form the mini world, and this one we are showing it diagrammatically, so which we call it as ER diagram. So we are showing it with respect to an entity relationship diagram. So once our ER diagram is ready, that is whatever we have, this one, this is all in explanatory, or this is kind of explanation is given in this case. That is, here it is written actually, okay, in words, sentences, it is written over there. That one can be identified with diagrams where it is easy to understand. And then from the ER diagram we apply the ER to schema mapping. Hope you remember there are around 6 to 7 rules are there, or what we call it as algorithms. Algorithmic steps are there. So if it is weak entity, what we have to show it as a ER diagram, in the ER diagram. And if it is 1:n, if the cardinality ratio is 1:1, 1:n, m:n, if the participation constraints are full or partial, so which key to be added where? That is, the primary key that is of one table can be a foreign key to in which of the tables. So all these things with respect to these rules, that is ER to schema mapping. So we have these rules, we have to understand these rules. Already you have seen these rules, and finally what we get is a schema diagram. So schema diagram. So in the schema diagram we are very clear with the primary key and foreign key constraints. And once this is ready, once the schema diagrams are ready, then we have to apply normalization. This is a general procedure what we need to do. We have to go for normalization. So schema diagram will give us general mapping, that is primary key and foreign key things. Whatever these ready, these tables what we have from the schema diagram, we have to do normalization. So normalization, we have 1NF, 2NF, normalization. So these are some of the normalization already these in 1NF, 2NF, 3NF, BCNF. So 1NF we are just deal with the atomic values where there is no further division of the attributes will happen. For example, if there are multi-valued attributes, so we need to make it sure that finally it is not harming the constraints or not harming whatever the ER diagram is providing, or whatever the schema diagram is providing. So that is finally our data, what we are having the data should not be what you call it as handling of the data should be easy. So 1NF deals with atomic values, 2NF this deals with full dependency, means there is a dependency, that is non-prime attributes are dependent on prime attributes or key attributes. So here all the non-prime attributes should be completely depend on the prime attribute or key attributes. So this is called as full functional dependency. By removal of any of the attributes still holds, that means if dependency exists, then we call it as partial dependency. So 2NF, what should actually look for full functional dependency. If any partial functional dependency is there, we should break it, or we should avoid partial functional dependency. So this is dealt in 2NF. Generally, this 2NF is applied for the tables where two keys, that is two keys together, if they have taken as a primary key generally, so in that case 2NF is more applicable. 3NF deals with trivial dependency. That means one attribute depends on the second attribute decides the third attribute. So hence the first attribute decides the third attribute. So this is like X arrow Y, Y arrow Z. We call it as trivial dependency. If such dependencies exist, we need to remove these kind of dependencies. That means again we need to break the tables. Normalization in the sense we are going to break the tables. Okay. So BCNF is Boyce Codd normal. So there is no much difference between a 3NF and a BCNF. But the conditions are, if it is in BCNF, it has to be in 3NF. But every table in 3NF need not be in BCNF. Okay. So BCNF generally deals with super key. But whereas in 3NF, there is no super key concept. That means all the attributes are generally dependent on the key attributes. But whereas in BCNF, it should be a super key. Okay. So this is what the normalization will do. We have to apply for each and every table, we have to apply these steps. Okay. And it is finally the database designer or we have to take a decision. So whether these are, after even doing these normalization, finally the meaning of normalization or the objective of normalization is to avoid the spurious or unwanted data to be stored like unwanted, it has to be stored in an unwanted way, like a confusing way, or duplication may also happen. Same data may be stored at many places. To avoid this duplication of the data, we have to do the normalization. Okay. So this is the general process of DBMS what we are doing. Then once the normalization is ready, so this part what we are seeing, this is the first part of the database design. This will come with respect to our database design. So this is all is conceptual. What we are seeing here is, this is the concepts that we are going to apply to get a base of the theoretical concept, or a base with respect to which we are coming up with the design aspects of the database. Any example is given, these are the first steps that you need to do. So once you get the normalization, you will have the tables, assuming the tables that we have generated. So these tables don't give any spurious tuples or duplicate data is being avoided. So this is the design aspect. So this part, what we are. So this part, what you are seeing. Okay, with respect to your course projects, so this part, so you need to do this part also in the course project. So already I have assigned you the different problem definitions, so which also you have understood in your first assignment. Already this was given for you to understand the concepts. So this is what is your subject course project. So up to here you need to go for the subject course project. DBMS theoretical course project is up to here. So whatever your problem definitions are there, we already have given you. So you have to identify the entities, attributes, constraints, ER diagram, schema diagram, normalization, then normalized tables. Okay. So up to here you need to do your course project. This is subject course project. Okay, this is the course project for DBMS subject. Up to here already I have discussed these things in the lab also. This is course project, what it should contain. This part, this part, complete part should be part of your course project. Now with respect to lab, now in lab also we are having a small project. So in the lab, what you are doing is, after completing all the experiments, what you need to do is, you need to actually implement it. This is the design part, this is the implementation or the development part. So whatever the normalized tables are there, these normalized tables, you have to create the tables. You have to create all the tables. You have to create all the tables with whatever the constraints have been identified. You have to create all the tables. Then you have to populate the real-time data, populate the real data, populate the real data. Okay, if you want to do the population of the real data, so you can just use your common sense, that is, and you can fill in the data here, you can populate the data here. Okay, and once this data is ready, then actually you need to have some UI here, that is user interface designs. User interface is required. So how this user interface is required? That is, actually to insert itself you need to have the real data. Now populate means you will be using insert. Yes, yes or no? Are you using insert function? Yes. So you will be using what? Insert SQL query, insert the data. Okay. So this is generally in SQL, what you type is the insert command, you type in the SQL. Now user interface should help you to populate the data or to extract the data. For example, suppose you are one table. Okay, so user interface designing I will discuss in another class. Okay, how to do this user interface, but this is what is required as part of your lab course project, lab project. Okay, user interface, right? So once this is ready, then there are some queries. What you need to do? Some simple queries you can have. You find out the general queries. So this is what is required with respect to, this is a lab project, DBMS lab project. Okay, so hope it is clear what you should do in and what you should do in lab project. So it is with respect to one problem definition which is already given to you. Okay, so this is the different things that you need to do. So is it clear? Okay, hope it is clear. If you have any doubt or anything, so you can just text me or you can mail me with respect to this. Okay, okay, so fine. Okay, so hope it is clear. Now coming up with respect to the report, you need to give the report to this. So with respect to the report, so we'll let you know whether you have to do report separately or one report containing everything. So where I think we can consider first part of it as a for the subject, and second part is for the lab project. Okay, so I'll just confirm about this, creating a single report or creating two different reports. Probably I think creating a single report is probably good, because it is having a flow, where in the same report I think we can have a division, a single binding, we can have a division as a course part and a lab part. So you need to carry one that single report during this course project also. And single can carry the same thing to the lab exams also. Okay. Okay, hope this is clear to you. Fine. Okay, now this is what this part already, whatever these things are there already, I think we have explored in our DBMS lab. So first two experiments, as I have discussed, right, were broadly discussed with respect to the ER diagram. Okay. Now third experiment, so which is the airline database. It is the airline database. So in third, fourth, and third, fifth experiment, fourth experiment, and and fifth experiment. Okay. So as compared to our previous two problem definitions, here there are no problem definitions. Directly there are tables, that is the tables are directly given to you. Okay. So in the third experiment, we have airline database where we have flights, aircraft, certified employees are the tables. Already it is given with what kind of data type the attributes will also have. So all the details directly we have given you the tables and the related attributes. Okay. What is asked here is you need to create the tables with simple create statements. Already you have identified foreign keys, primary keys, everything is clear with respect to the given things. And then there are queries. Directly we have asked you to give several queries. Okay. So schema diagrams you need to draw followed with the SQL queries. So your work is what? Create the tables, populate the data, and then whatever the queries are given listed here, you need to write the SQL queries for this, and whatever the results you have, that results you need to show. This is what you need to write as a SQL queries. So third experiment deals with airline database. Already I think this also we have done in our lab. Fourth one is order database. Okay. So fourth one is order database. Okay. So let me explain you about this order database. It contains three tables. We'll just explore this order database. So it contains salesman table. It contains salesman table. Okay. So here there is the schema diagram is, it is a salesman ID. Then we have name of the salesman, then the city, and then whatever his commission is there. So here salesman ID is the primary key for this. Second table is customer. So here we have customer ID is the primary key, then customer name, okay, then city, then grade, and then salesman ID. Okay. So salesman ID in the sense, why we have salesman ID? Because there is a link between customer and salesman. This salesman have sold some items to this customer. So to manage that, that is which customer have been taking the products or have been took the product or bought the product by which salesman. Then order. Okay. So order. Then okay, and then order. and then you have stored it. Okay. So order number is a primary key here. Now schema diagram in the sense what we need to show. So we need to show the link between these tables. So here this sale ID is a foreign key because it is a primary key here. Okay. And here this customer ID is a foreign key because it is a primary key here, it is a foreign key here. Similarly, there is sales ID which is again will be pointing here. Okay. So this is our schema diagram. Right. So this is how the schema diagram looks. Now we will create the tables. So how to create the tables? Probably already you know how to create the tables. So I think it is very simple, but we need to add a small constraints here when we are creating the tables itself. For example, with respect to the queries what we have asked. So here we need to demonstrate the update and delete cascading effects, that is cascading. Okay. We need to show that what happens, the cascading effect on deletion. We will see how to do that. Okay. So these tables are the schema diagram of the tables. Now this table creation is simple. Create table salesman, sales ID, name, city, commission. Sale ID as a primary key. Coming to customer. So customer, this is also simple. Create table, customer, customer ID, customer name, city, grade, sale ID. But here what you have to do, foreign key. So the last statement you remember, other statements remain same. Only when you are adding the last this one constraint, what you need to do is you need to write this foreign key, which is the foreign key here, that is salesman ID. Okay, references where, that is salesman, which key, salesman sale ID. If we would have written this, it is just a foreign key constraint. But apart from this, you need to write this also, on delete set null. Means here we are demonstrating, this is the end of our create table. So you create everything here, create customer, all other things you know. Okay. So I need to show only adding of this line. So foreign key, sale ID references, salesman sale ID. If you write only up to here, what it will show, you are just adding the foreign key constraint. But what this line will tell you, that is, if you delete the salesman ID, okay, then by default it should be set to null. That is, if you delete that salesman ID, then automatically the null should be inserted over there. This is what the meaning of this. Okay. Then there is another table, orders. We'll see what will happen if we delete it, order table. Hope you have understood this. Similar to this, there is create table order. So create table order. So here there are two foreign keys are in this. So customer ID and sales ID. Now this what it is showing, order number. See here, this order number is what, on, that is this customer from this salesman on this date giving this much of amount have purchased some product. This is what the table is containing, or he has ordered some product or he has purchased some product. This is what the table that it is showing. What it is showing, on this date this customer from this salesman have purchased, or in other way, this salesman have sold a particular product to this customer on this date with respect to, which was with respect to this cost or this amount. So that will be stored with respect to this order number. Okay. So this is how it is being stored. Now suppose I want to delete this order number. I want to delete the order number. Okay. Or suppose order number means I can directly delete it without affecting any customer ID and sale ID. Now suppose I want to delete this customer from this. Customer ID I want to delete. Or suppose this customer is not existing. I want to delete this customer because sometimes it may become invalid. Because of some reasons I want to delete this customer. Or this salesperson left the job. So I want to delete all the transactions that this salesperson has done. So whichever his entries are there, see, I can only delete salesman from here. Okay. Then if I delete the salesperson from here, if he left the job, then I will delete all the details. I have to delete all his details. But in this case, only I can delete it from salesperson, that is salesman table. I will delete one row from here. That particular salesman is left the job, so I have deleted from here. But how about in this table? How about in this table and how about this table? Still, even though I have deleted from this, their entries still exist here. And one more thing is, I cannot directly delete from here because this salesman is being referred in two different tables. So directly I cannot delete a salesman, okay, because from that table it is being referenced in other tables. So I cannot directly delete it. So in that case, what should I do? First I have to delete, that is in this case, first thing is I have to go to customer table and I have to delete this separately I have to delete. Then I have to come to this order and I have to delete this also. So two deletes I have to make. Then I have to go to this table, salesman table, and then I have to delete it. If I have to delete one single entry from, if that is whichever the salesman have left the job. So what should I do? I have to come to customer, I have to delete. Then I have to come to order, then I have to delete. Then I have to go to salesman table and then I have to delete that salesman ID. This is what the general procedure. If it is okay, if there are 3 tables are there, then it could be easy. If there are hundreds of tables, then it's very difficult to go to each and every table and to delete the entries. So in that case, what we should do? We have to do something called as cascading delete. That means if we delete at one place, then by default or automatically it will be deleted wherever it is being used. Okay. So here, that we are going to demonstrate here. So create table orders. So here, what is done? Foreign key sales ID references, same thing, salesman sales ID. Okay. Here on delete, we will be doing cascade. This is one entry. Similarly, second entry, what is that? One more thing, foreign key, customer ID, references, customer, cust ID. Okay, this also on delete, cascade. Okay, this is these two statements we need to add with respect to create order table. Okay, so hope you have understood why this on delete cascade is required. So in this experiment we are going to demonstrate that on delete cascade. So once our tables are ready, what we should do? So we are going to populate the data. Okay, so we are going to populate the data. Okay, now populate the data by using insert statements. So for that, what we should do? See, directly I cannot go and create the order table here. Step by step I have to create, because see here I cannot even create customer also, insert customer also, because there is something, it is dependent on salesman. If salesperson exists, then it is better to add here. Otherwise, what should I do? I have to add empty here, or some value I have to add, so which it may not take because it is not existing here. So you have to be careful when you are inserting or when you are creating the table. Okay. So now in this case, let us look at salesman, right, table. So there is sales ID. So this is the ID. Let me write here. This is the ID. Then this is the name. Then this is the city. What is our first query here? Oh, fine. So ID, name, city, commission. Okay. So ID I have got 1000, 2000, 3000, 4000, and this could be any number, 5000. Then name is, there is Raj, Ashwin, Kiran, Surya, Arun. City is Bangalore, Belgaum, Udupi, Tumkur, Bijapur. Okay. And some commission. So he could have 50%, this fellow have 40%, this may have 50%, 20%, some commission rate. Okay. Then this is our this table. Okay. Next. So we have got customer ID, customer name, then we have city, then we have grade, then we have salesman ID who have sold. Another table. So ID is customer. This is Infosys. We have entered cities. Salesman ID here. Salesman ID here. 1000, 2000, 1000. So this is the table for customers. So now we'll have one. Okay. Now count the customers. Count the customers with grades above Bangalore's average. Okay, so this is the query. We want the number of customers. How many customers are there with grades above Bangalore's average? Bangalore's average in the sense city. So here. Okay. So what we should write the query for this? So we have select, count. So from which table? So which these two tables are involved in this? So select, count. What we should count? We can count customer ID here. Select, count, cust ID from customer. Okay, where? So what we should write? Where? Where the grade should be less than 3. So where grade, this is a query within the query, nested query. So select, average is a average, grade from customer. So this is the query here. So what are we looking for? So we need to count the number of customers where the average grade from customer where city is Bangalore. Okay, so you need to count the average grade. So there is Bangalore, and average, and yeah, we need to find the customers with grades above Bangalore's average. So we need to find out which are there above Bangalore's average. So Bangalore's average in the average grade from customer where city is Bangalore. So what this will return, let us see what this query will give us. Select average grade from customer where city is Bangalore. So there are two cities, 5 and 4. Okay, so 5 and 4 are the 5, 4 are the two values, 5 and 4 grades. So what is the average of 5 and 4? So if you take it, it is 9, so it is 4.5. So if it is 4.5, it will consider as 4 here. In this case, it will round off that. So 4 it will take. So average is 4 now.